Integration, numerical integration, the Trapezium Rule. The idea with numerical integration is we're trying to integrate something that we can't integrate using our normal methods so far. So we're going to have to approximate the area under the curve. Approximating the area under the curve approximates the integral, so we get an approximate value for it. The better the approximation, we can do that by adding in more parts to it. So in this case, we're looking at chopping up all the areas under the curve and making them all into trapeziums. It makes sense for us to use trapeziums all of the same height. Now you're going to have to stick your head on its side to see that the height is between these lines. We're going to use trapeziums with two right angles in, and the side where the curve is going to be an approximate to the curve. So that's going to be a straight line instead of curved. The area of each of these trapeziums is going to be the lengths of these lines. So y0 and y1 times by the height, h, divided by 2. So that's just your area of your trapezium, h over 2 times y0 plus y1. And then the next one's going to be h over 2 plus y1 plus y2, and then so on all the way up to the end. But what you'll notice here is that y1 has come up twice, the y2 will come up twice, but the ones on the end, y0 and yn, will only come up once. So we can write the formula as integral between a and b of y in terms of x is going to be half h, squiggly brackets, y0 plus yn plus 2 times everything else, where h is b minus a over n, and n is the number of trapeziums that you're using, not the number of lines, because you started your first line with a y0. It's easier to see h as the gap between all your x's. An example to show this. Find the approximate value for the area under the curve y equals 12 over x between x is 2 and x is 5. At the moment we've got no better way of integrating this, because if we wrote it as 12x to the minus 1, add 1 to the power divided by the new power, dividing by 0, not a good idea. So what we're going to do is we're going to use only a few trapeziums between x is 2 and x is 5. I'm going to take every integer between them. So I'm going to look at the y values I'll get from my formula. 6, 4, 3, 2.4. My h is my gap between my x's. So I'm going to use h as a 1. So I get half times h times y0 plus yn. So that's going to be 6 plus 2.4 plus 2 lots of everything else. 4 plus 3. So that's going to be half times 8.4 plus 14. So that's going to be 11.2. Thank you.